Betelgeuse, the dying giant in our night sky. On a clear winter night, look for the constellation Orion. You can recognize its center by three bright stars arranged in an almost perfectly straight line. Above them lies a striking orange-red point of light marking one of Orion's shoulders. That star is called Betelgeuse. From Earth, it appears calm and insignificant. In reality, it is an enormous, turbulent star approaching the end of its life. Its surface pulsates, its brightness changes, and it ejects vast amounts of its own material into the surrounding space. One day, Betelgeuse will explode as a supernova, and its familiar red point of light will disappear from our sky. What is Betelgeuse? Betelgeuse is a red supergiant. This is one of the final evolutionary stages of a very massive star. Red supergiants form when massive stars begin to run out of their primary fuel in their cores. Their internal balance changes, causing their outer layers to expand dramatically. The star grows to an immense size, its surface cools, and it takes on a distinctive orange or red color. The surface of Betelgeuse has a temperature of approximately 3,500 degrees Celsius. That is cooler than the surface of the Sun, which reaches about 5,500 degrees Celsius. Despite this, Betelgeuse radiates an enormous amount of energy because of its extraordinary size. It is not a calm, perfectly spherical star like the ones we see in textbooks. Its outer layers pulsate and change shape. Vast regions of hot plasma move across its surface, while some of its material regularly escapes into the surrounding space. Betelgeuse resembles a gigantic, restless ocean of glowing gas. Where is it, and how far away is it? Betelgeuse is located in the constellation Orion. From the northern hemisphere, it is easiest to find during the winter months. Its orange-red color makes it relatively easy to distinguish from the other bright stars around it. Its exact distance is not entirely certain. Different measurements place it approximately 600 to 700 light-years from Earth. 1 light-year is the distance light travels in an entire year, nearly 10 trillion kilometers. This means that light from Betelgeuse takes centuries to reach Earth. When we look at it today, we do not see Betelgeuse as it is now. We see light that left its surface during the Middle Ages. In theory, Betelgeuse may have already exploded, with the light from that event still traveling toward us. However, this is considered unlikely. Current estimates suggest that the star may continue to exist for another 100,000 years. How large is it? Determining the exact size of Betelgeuse is difficult because its outer layers are thin, constantly moving, and have no clearly defined boundary. The best way to understand its immense size is to place it at the center of our solar system. If Betelgeuse replaced the Sun, it would swallow Mercury, Venus, Earth, and Mars. Depending on the estimate, its outer edge could extend somewhere between the orbits of Mars and Jupiter. Our planet would not even be visible inside it. Compared with Betelgeuse, Earth would be smaller than a tiny grain. Hundreds of millions of suns could theoretically fit inside the star by volume. But this does not mean Betelgeuse is hundreds of millions of times more massive. Its mass is estimated to be somewhere between several and a few dozen times the mass of the Sun. The star's enormous volume consists of extremely thin gas. Betelgeuse is so large because it expanded dramatically during the final stage of its life. How did Betelgeuse form? Betelgeuse formed approximately 10 million years ago from a vast cloud of gas and dust. Gravity gradually pulled the material together until the pressure and temperature at its center became high enough to ignite nuclear fusion. A new star was born. From the beginning, Betelgeuse was significantly more massive than the Sun. As a result, it produced tremendous amounts of energy and shone with extraordinary intensity. But there was a high price to pay for its size and brightness. Massive stars consume their fuel much faster than smaller stars. The Sun has existed for about 4.6 billion years and is roughly halfway through its life. Betelgeuse is only around 10 million years old, yet it is already approaching its end. The largest stars do not live the longest. They live the most intensely. When Betelgeuse consumed much of the hydrogen in its core, it began to change. Its core contracted and grew hotter while its outer layers expanded. The once hot star gradually transformed into the red supergiant we see in the sky today. What makes it special? Betelgeuse is one of the few stars whose surface we can at least partially observe from Earth. It is also bright enough to be seen without a telescope. But it attracted the most attention near the end of 2019. Its brightness began to fall unexpectedly. Over the following months, Betelgeuse became so faint that the change could be noticed with the naked eye. Some people began to wonder whether the star was preparing to explode. Later observations, however, revealed a different story. Betelgeuse had ejected a large amount of hot material from its surface. As this material moved away from the star, it cooled and formed a cloud of dust. From our point of view, the dust obscured part of the star, making it appear significantly dimmer. The star itself had not stopped shining. Some of its light had simply been blocked by material that Betelgeuse had ejected. The event, now known as the Great Dimming, demonstrated just how turbulent the life of a red supergiant can be. Betelgeuse is constantly pulsating, changing in brightness, and losing mass. What would we see up close? Imagine a spacecraft finally approaching Betelgeuse after centuries of travel. At first, we would see an orange-red point of light slowly growing larger. Gradually, it would begin to fill the entire sky until an unimaginably vast wall of glowing plasma stood before us. We would not see a solid surface. Betelgeuse is made of gas and plasma, so there is nowhere a spacecraft could land. Its outer layers would resemble enormous moving clouds. We would observe gigantic convection cells in which hot material rises from inside the star, cools, and eventually sinks again. Each of these regions could be larger than the entire Sun. The area surrounding the star would be filled with gas and dust that Betelgeuse had expelled throughout its life. The star itself would be enveloped by a vast and irregular shell of material. A spacecraft, however, could not approach too closely. The intense radiation and extreme temperatures would destroy it long before it reached the star's visible surface. What does the future hold? Deep inside Betelgeuse, increasingly heavy chemical elements are being created. The star is gradually consuming its remaining fuel, and each stage of its life is becoming shorter than the one before it. Layers resembling those of an onion may form inside the star. A different type of nuclear fusion takes place within each layer. This process will continue until iron begins to accumulate in the core. That is when the problem begins. Fusing iron will no longer provide the star with the energy it needs to resist its own gravity. Once the core can no longer generate sufficient pressure, it will collapse in a fraction of a second. The resulting explosion will tear apart the outer layers of Betelgeuse and hurl them into space. Betelgeuse will become a supernova. From Earth, it could appear as an extraordinarily bright point of light, potentially visible even during the day. At night, it might become bright enough to cast faint shadows. Despite this, it should not harm us. Betelgeuse is far enough away that its explosion would not pose a serious threat to our planet. After several weeks or months, its light would begin to fade. Orion's familiar shoulder would eventually lose one of its brightest stars. The collapsed core of Betelgeuse will most likely leave behind a neutron star. If the remaining core is massive enough, however, something even more extreme could form, a black hole. The material expelled by the explosion will spread throughout the surrounding space. Over millions of years, it may become part of new clouds of gas and dust. One day, new stars and planets could form from them. Perhaps even worlds that do not yet exist. When we look at the red point of light in the constellation Orion, we are not simply looking at a dying star. We are witnessing one stage in an endless cosmic cycle. One day, Betelgeuse will disappear. But the material it leaves behind may begin an entirely new story. Thanks for watching, and I'll see you next time.